Our slides. It is. You can pull this there.
Yeah. And I think your microphone is on.
Okay, everybody, can you hear me? No. Can you hear me now? Oh. I don't hear you. Okay, we're going to get started tonight. Welcome to the RASC meeting for February. Our first speaker is Gail. I think it's a little too loud. And then we'll with the beginner session.
Oh no, Judy has it.
Am I on? Can you hear me? Yes. Okay, can I get set up?
Which microphone? Yeah, just use
Should just be the next slide.
Is the mic on? Can you hear me? Yes.
And drop the lights.
Okay. Or.
So it's just the arrow keys.
Okay.
What's going on?
Now can you hear me? Yes. In honor of tomorrow being Valentine's Day, we are going to look at the goddess of love. People have been looking at the planet Venus for thousands of years. It's not the largest planet in the solar system, but its closeness to Earth makes it the brightest planet in the sky. It's the second planet from the sun, and it's the second brightest object in the night sky. Only the moon is brighter. Its magnitude is between minus 3.8 and minus 4.6. So Venus is so bright it can be seen in the daytime on a clear day, if you know where to look. But be careful not to look close to the sun. Venus is the second largest terrestrial planet, and it's sometimes referred to as Earth's sister planet because of their similar size and mass. There's only a difference of 638 kilometers in diameter, and Venus has 81.5% of the Earth's mass, so just about 20% less. Both planets have a central core, a molten mantle, and a crust. Of all the solar system planets, Venus is the closest to being a twin of Earth. The orbit of Venus is also the closest to Earth. It's 108 million kilometers from the sun, and Earth is about 152 million. Both worlds have relatively young surfaces, and both have thick atmospheres. However, it's worth noting that Venus's clouds are made mostly of poisonous sulfuric acid. Venus is known as the morning star and the evening star. Many early civilizations thought that Venus was two different bodies. The Greeks called them Phosphorus and Hesperus. Phosphorus means light-bearing because in the dark and in moist air, phosphorus glows with a dull white light. The Romans called the two bodies Lucifer and Vesper. Lucifer was the personification and god of the morning star, and was one of the many sons of Aurora, the goddess of the dawn. The Latin word Luciferus and the Greek word phosphorus mean exactly the same thing, bringer of the light. This name was given to this god because he was the last star of the night sky to be visible on Earth before the sunrise. One of his brothers, named Hesperus, meaning evening or dusk, was the evening star, being the first visible star in the night sky. Around 500 BC, the Greek mathematician Pythagoras realized that the morning and evening stars were in fact the same planet, at which point Phosphorus and Hesperus became merely alternate names for the same star god in his brighter and darker aspects. This is because when Venus's orbit around the sun overtakes Earth's orbit, it changes from being visible after sunset to being visible before sunrise. However, the ancient Sumerians already knew that the morning and evening stars were the same celestial object. They associated the planet with the goddess Inanna, who was known as Ishtar by the Babylonians. She had a dual role as a goddess of both love and war, thereby representing a deity that presided over birth and death. Then, for some reason that I could not find, the Greeks named this planet after the goddess of love and beauty, Aphrodite, and the Romans knew her as Venus. Mayan astronomers made detailed observations of the planet Venus as early as 650 AD, and the ancient Babylonians tracked her wanderings through the sky in records that date as far back as 3,600 years ago. The ancient Mayan people associated Venus with the rings because one of the planet's configurations periodically accompanies the arrival of the rainy season. Venus was considered the most important celestial body to the Mayans, who called it the Great Star. They monitored the movements of Venus very closely, and they observed it during the daytime. The positions of Venus and other planets were thought to influence life on Earth, so the Mayans and other ancient Central American people timed wars and other important events based on their observations. In the Dresden Codex, the Maya people included an almanac showing Venus's full cycle in 5 sets of 584 days each, which is approximately 8 years, after which the patterns repeated, since Venus has an orbital period of 583.92 days. The Dresden Codex is a book dating back to the 11th or 12th century. The Mayan people developed a religious calendar based in part on the motions of the planet, and they held the motions of Venus to determine a favorable time for events such as war. They also named it the Wasp Star. The Maasai people of Kenya tell a story of Kalikan, who was an orphan boy. The boy befriends an old farmer and tends his cattle, as long as the old man agreed not to pry into the boy's only secret, his origin. When the man betrayed his trust and spied on Kalikan, the boy vanished in a bright light and returned to the heavens as the planet Venus. Among the Mapuche people of south-central Chile and southwestern Argentina, this planet was called Winalevi, or the first. It was believed to have existed when spirits were attempting to ascend back from the world below after falling from the middle world. The planet is believed to be an amalgamation of some of those spirits who were stuck on their way. Venus is a very important symbol for these people. It was eventually incorporated into the flag of Chile, simplified as a 5-pointed star, symbolizing a beacon of progress and honor. The dense clouds of sulfuric acid that surround Venus make it impossible to view the surface from the outside the atmosphere. It was only when radio mapping was developed in the 1960s that scientists were able to observe and measure the extreme temperatures and hostile environment. Only 4 spacecraft have ever returned images from Venus's surface. The world next door does not make it easy, with searing heat and crushing pressure that quickly destroy any lander. In 1975 and 1982, 4 of the Soviet Union's Venera probes captured our only images of Venus's surface. The Veneras, which means Venus, in Russian, scanned the surface back and forth to create panoramic images of their surroundings. They revealed yellow skies and cracked, desolate landscapes. And these pointy things on the bottom, those are not teeth from some monster, that's just part of the land here. Venus is the hottest planet in our solar system. So you might think that it might be a tropical paradise, just right for your winter vacation with your Valentine. But the average surface temperature is 462 degrees Celsius. And because Venus has a very small axis tilt, only about 3 degrees, there are no seasons. The dense atmosphere is about 96% carbon dioxide, so it traps heat and causes a greenhouse effect. The surface is hot enough to melt lead due to its runaway greenhouse atmosphere. So if you decide not to take my advice and you do travel there, be careful what you use to build your station. Atmospheric pressure on the planet is 92 times greater than the Earth's, so it's about the same as water pressure on Earth, about 1 kilometer under the ocean. If you weigh 100 kilograms on Earth, you would weigh 92 kilograms on Venus. Winds in Venus's middle cloud layer swipe across at super fast speeds that can reach 724 kilometers per hour. These Venusian winds are faster than the speediest tornadoes on Earth. There are more volcanoes on Venus than on any other planet in the solar system. Astronomers know of more than 1,600 volcanoes on its surface, and there are likely many more that are too small for us to see. Probably most of these are dormant, but many may still be active. More than 1,000 volcanoes or volcanic centers larger than 20 kilometers have been found on the surface. The largest volcano is called Mount Mons, and it's 8 kilometers high, and there are 6 mountain ranges on this planet. A day on Venus lasts almost a year on Earth. It takes 243 Earth days to rotate once on its axis, and its orbit around the sun takes 225 Earth days compared to the Earth's 365. So this must be a really screwy place to live. I don't know how you could ever plan your day. Venus rotates counterclockwise, the opposite direction that the Earth spins. This is known as retrograde rotation. It also differs from most other planets in our solar system by having no natural satellites. Venus is rare among the planets, as we can see it cross in front of the sun. Only Venus and Mercury do this from our point of view on Earth. Venus transits occur rarely, with pairs separated by 8 years, coming around just less than once per century. Venus experiences a phenomenon similar to the northern lights. They're called the Venusian blows. Because Venus orbits the sun within Earth's orbit, the planet appears to have phases like the moon. When Venus is on the opposite side of the sun, it is in full phase, and it appears in new phase when it's between the Earth and the sun. The first person to witness these phases was our friend, the Italian astronomer Galileo, in the year 1610. He observed that Venus appeared in phases in our sky similar to the phases of the moon. This was evidence that Venus orbited the sun, and so he contributed to the downfall of the belief that the sun and the planets revolved around the Earth, which had been accepted for centuries. Nicholas Copernicus was a Polish scientist who lived about 100 years before Galileo. He had already come up with the unorthodox idea that the sun was at the center of the solar system. Galileo knew about it, and he had accepted Copernicus's heliocentric or the sun-centered theory. It was Galileo's observations of Venus that proved the theory. Using his telescope, Galileo found that Venus went through phases, just like our moon. But the nature of these phases could only be explained by Venus going around the sun, not the Earth. Galileo concluded that Venus must travel around the sun, passing at times beyond and behind it, rather than revolving directly around the Earth. Galileo's observations of the phases of Venus virtually proved that the Earth was not the center of the universe. It was this statement that most angered the church leaders of the time. It took more than 350 years for the Catholic Church to finally pardon him. But it shouldn't have been a pardon because he was right anyways. This planet was named after the Roman goddess of love and beauty, and the Greeks knew her as Aphrodite. The ancient Romans identified Aphrodite with their goddess Venus, who was originally a goddess of agricultural fertility, vegetation, and springtime. Along with Athena and Hera, Aphrodite was one of the three goddesses whose feud resulted in the beginning of the Trojan War. All the gods and goddesses, as well as various mortals, were invited to the marriage of Peleus and Thetis, who were the eventual parents of Achilles. Only Eris, the goddess of discord, was not invited. She was annoyed at this, so she arrived with a golden apple inscribed with the words, "For the fairest," and she threw it among the goddesses. Aphrodite, Hera, and Athena all claimed to be the fairest, and thus the rightful owner of the apple. Instead of fighting it out, which might have been really entertaining knowing how some of these Greek stories told, the goddesses chose to place the matter before Zeus. Zeus did not want to favor any of the goddesses, so he put the choice into the hands of Paris, a Trojan prince. After bathing in the spring of Mount Ida, where Troy was situated, the goddesses appeared before Paris for his decision. All three goddesses were identically beautiful, and Paris could not decide among them, so they resorted to bribes. Hera tried to bribe Paris with power over all Asia and Europe. Athena offered wisdom, fame, and glory in battle, but Aphrodite promised Paris that if he were to choose her as the fairest, she would let him marry the most beautiful woman on earth. This woman was Helen, who was already married to King Menelaus of Sparta. Paris selected Aphrodite and awarded her the apple. The other two goddesses were furious, and as a direct result, they sided with the Greeks in the Trojan War. Naturally, love was one hot topic among the ancient Greeks, and the number of romantic stories is astounding, although most of them are tragic. Of course, the Greeks honored love, but surprisingly, they did not particularly glorify Aphrodite, the goddess. Her nicknames show how the Greeks really felt about this powerful emotion. She was Androthinus, the killer of men, Epimenidia, she is upon the graves, and Melena, the blackened one. Aphrodite has no really important festivals, and her favorite lover was Ares, the god of war. And I think I can see why. We know him better by his Roman name of Mars. And this is a picture I took of that conjunction, I don't know, maybe 10 years ago. I was up at Glenley and I happened to snap that. That's one of about 3 pictures I've ever taken in my lifetime. Sharing it with Yep. Aphrodite, by the way, was married to Hephaestus, smith god. Unfortunately, she did not seem to be aware of this fact. She had many lovers among the gods and mortals. One story was invented to explain Aphrodite's marriage to Hephaestus. Zeus hastily married Aphrodite to Hephaestus in order to prevent the other gods from fighting over her. In another version of the myth, Hephaestus gave his mother Hera a golden throne, but when she sat on it, she became trapped, and he refused to let her go until she agreed to give him Aphrodite's hand in marriage. Hephaestus was overjoyed to be married to the most beautiful woman on earth, and he forged her many fine pieces of beautiful jewelry. But one day, when Aphrodite and Ares lay secretly together in her bed, Helios, the sun god, observed the lovers and told her husband. Hephaestus went to work in his shop and made a trap of an invisible net. The careless lovers fell into the trap. Hephaestus brought all the gods into the bed chamber to laugh at the captured adulterers. But instead of sympathizing with the husband, they sided with Ares, and they all began to laugh hysterically. Zeus punished Aphrodite by making her fall into unrequited love with the mortal. Now, I find this very surprising because Zeus himself had a great deal of experience with extramarital love affairs. Aphrodite's overwhelming passion was for Adonis, but she had to share him with Persephone, the queen of the dead, who we see in the spring sky as the constellation Virgo. Neither woman wanted to share him, so to settle the dispute between them, Zeus ruled that for 1/3 of the year, Adonis was to live by himself, for another third with Persephone, and the remaining third with Aphrodite. I was watching an old movie, Sherlock Holmes and the Spider Woman. Remember those old Basil Rathbone movies? Well, I didn't realize there would be real spiders in it, but by that time I was committed. So Sherlock Holmes and Dr. Watson were chasing the bad guys, and they ended up in a carnival. And in the carnival was a fortune teller, and outside of her tent was this sign. So I looked up the line of Venus, and it signifies a compassionate and open-hearted character, which is kind of irrelevant. If you're interested in movies about Venus, we have the riveting tale of The First Spaceship on Venus from 1960 and The Stranger from Venus from 1954. I do not recommend either of these, and I like old dumb movies like that. Even though Patricia Neal was in one of them, even she couldn't save it. But then we have this one. Abbott and Costello go to Mars. Through a series of humorous events, Abbott and Costello ended up on a rocket ship that was supposed to go to Mars, but being Abbott and Costello, they ended up on the planet Venus. And Venus was full of beautiful women and no men. And well, you know, this one was kind of fun. And you can find all of these on YouTube if you're interested. And we also have this, the Venus flytrap. This plant is not from Venus. It supposedly got its name because the flowers are very beautiful, like the goddess Venus, and they're white, like the planet Venus in the sky. And the flytrap part is because it eats bugs. Ick. Native Indigenous mythology is rich with stories and symbols that reflect the values, beliefs, and traditions of the people. Central to this mythology is the figure of the morning star, a powerful symbol of hope and renewal. The morning star is considered a celestial guide. It represents new beginnings and the promise of a new day. This bright star is associated with the dawn, and it's seen as a herald of light in the darkness. Their creation myths often incorporate the morning star as a vital component to the formation of the world. These stories illustrate the interconnectedness of all beings and the natural world. In some stories, the morning star is depicted as a being who descends from the heavens to assist in the creation process. It is believed that the morning star helped to establish the laws of nature and the cycles of life, emphasizing the importance of harmony in the universe. The journey of the soul after death is an important aspect of their spiritual worldview. The morning star serves as a guiding light for the soul's transition into the afterlife. The soul embarks on a journey after death, navigating through various challenges and trials. The morning star is seen as a beacon of hope, illuminating the way for the deceased. As souls travel towards the afterlife, the morning star provides comfort and guidance, reassuring them that they are not alone on their journey. This connection emphasizes the enduring bond between the living and the spirits of their ancestors. Rituals often include offerings and prayers directed toward the morning star. These practices serve to honor the star's role as a guide and protector, reinforcing the community's connection to their spirituality. Niabi Anang, which shines at nightfall, and Waban Anang, which rises the following dawn, form together one star named Pizag Anang, the day star. In many sacred stories, dawn and evening live on to this day as grandfathers. Neither one is more powerful than the other, and they continue their duels, thus symbolizing the eternal conflicts and dualisms within the human soul and in human society. Another name for this planet, I am not going to try to pronounce this, forgive me, It translates to the bright planet that spins backwards. The Giza Ganang is depicted in the form of the round yellow-brown celestial body. Spirit of the Waban Anang, or the morning star, is symbolized by the gold, turquoise, and rose quartz pendant in the foreground. Even though our goddess of love is known as the evening star and the morning star, she's not visible in the evening or in the morning right now. She's behind the sun. But in the next couple of weeks, she will rise in the evening and she'll be much better on later in the year. So when you have a chance, go out and take a look at Venus and see just how beautiful she is. The end.
Questions?
Thanks, Gail. Okay, next one. Where's mine? Okay. So, with the end of the beginner session now, we'll begin, the full meeting. The first will be, land acknowledgement. So the lands from which our members and guests are joining us are located on original lands of Anishinaabe, Cree, Oji Cree, Dakota, and Dene peoples, and the homeland of the Métis Nation. We respect the treaties that were made on these territories, acknowledge the harms and mistakes of the past, and dedicate ourselves to move forward in partnership with Indigenous communities in a spirit of reconciliation and collaboration. Okay, so we'll start with, oops. Sorry, didn't break. Start with some announcements. Important for the next meeting is that now nominations are open for 2 positions on council. One is for a councillor and one is for a secretary position. Okay. I have tonight the pleasure of awarding Adam Gear with a significant for Explore the Moon. Can Adam come down? So I have all of what Adam submitted, which is amazing work. People should know that this isn't a trivial thing, and very few of our members actually do this, so congratulations. And I encourage you to talk with Adam about what it took to do this and his other certificate, which he got not that long ago.
It's been a busy first year.
That's busy first year. So I see great things in the future for you. And thanks very much for being so keen on
Of
this.
course, it's been super enjoyable.
Good.
Look forward to talking about it.
Good. Thank you.
We go down.
Okay, the Observatory Committee, chaired by Ed Wright, has issued a survey by email. Please complete this to tell us about what you use at the observatory, if you use the observatory, the warm room, the pad, one or all of the above, and how you would like it to be, what would make it better, what's the main reason you use it or don't use it. Really just input, because we have some decisions to make about what to do with various buildings and facilities, how we would like to change them, if we would like to change them. So there was an email sent February the 4th, and the URL for the survey is written there in yellow, forms.gle, and then a bunch of letters and numbers. So it's in the email. If anybody lost the email, can't find it, you can find me or find Mark Irvine or James Fast or Ed on the website, and we will forward you that email. Okay. Okay, so we have a number of programs in the club. The Explore the Universe Certificate Program, which is coordinated by Stan Runge so far. Stan's here tonight if you want to speak with him. There his hand is up. We have a telescope loaner program, which is pretty popular. There's all kinds of equipment in that program. Mike Caracas coordinates it. There's even a Sea Star that you can borrow. Mike's at the back there. And you need to sign up, and then he needs to tell you all about the instrument that you'd like to borrow and give you a little bit of a training on it if you're not familiar. And then you can borrow it for a month or more, depending on demand. A lot of people start out with that, try out 2 or 3 instruments, and then give in and buy their own, or buy one and then borrow another just for change. It's a pretty neat program. We're always soliciting ideas for workshops, which are one of the benefits of membership, and Stan also is coordinating those. There is one coming up, which I'll say more about in a minute. But if you do have ideas for workshops that are usually held on a Saturday or Sunday afternoon, please give Stan a heads up or some ideas. We are seeking volunteers for an event, an outreach event at the Living Prairie Museum, which is being coordinated by Wing at the back. If you're interested in joining in, that's one evening. I think I've got the times later, 7 to 8:30 or something like that. And members only nights, we're always asking volunteers, especially from council, but if you're going to go and you are trained on things, you can also probably host. Next month's meeting is the meeting in which we have the annual general meeting at the start. And that's open to all members, and that's the time when you will hear report from council, report on the budget, and be voting for the secretary and council positions that are open.
Judy,
Yes,
just a comment about members observing night, which is typically,
I've got it here.
yeah, but we postponed it to next week,
Yeah.
Friday.
I've got it on this.
Right there.
Yeah.
Never mind.
It's
Ah,
members observing night is usually the night after the meeting. So it should have been tomorrow, but I thought with the council folks agreeing that Valentine's Day probably wasn't a great night if you were interested in watching Venus go behind the sun again, or stay behind the sun with your sweetie or whatever. But we've postponed it to next Friday, and the reason it's Friday is because there's a workshop on the 21st, afternoon of the 21st. Okay, so I put a list of upcoming events and some dates and times together because there were just too many to fit in the announcements page. So I've just said the 20th of February, the Friday, is Members Observing Night, and Wing and James are going to be hosting that. There's a Star Tools imaging workshop on Saturday, February 21st in the afternoon, 1:30 to 4:30, and that'll be at Launch Co-working, which is on Lombard, where the holiday party was in January. It's on the 5th floor. And Wing and Stan, I believe, will be hosting that. And Richard will be giving the workshop. RASC National is hosting a Stellarium Level 1 training, which is a useful program for all people who might be interested in imaging the sky on the computer. It's at 2:30 online, Tuesday, February 24th. Possibly not the most convenient, but you need to register by email, and that was in one of the last newsletters from RASC National. Yes, Stan?
Is that CST? Is that?
This is the Winnipeg time.
Okay, thank you.
Spruce Woods is a little ways off, but just so you know, it's September the 10th to the 13th, 2026. So this will be longer darkness, cooler nights likely. And after all the people have pretty much vacated the campsite unless they're super dedicated. Okay, outreach. Living Prairie Museum, as I said earlier, March the 12th, 7 to 8:30. And these all need volunteers and people to go and help out and just greet people and answer questions. There's a spring telescope tune-up on March 28th, which is a really popular event. Members bring equipment, get tips on collimating, cleaning mirrors, how to photograph certain things, how to use certain pieces of equipment, what to watch for, and generally speaking, exchange tips on equipment. That's at Eastview Community Church, which is just about as far north as you could go inside the city. But works out quite well, actually. Spring Astronomy Day is Saturday, April 25th, and Science Rendezvous, which happens at the University of Manitoba, is Saturday, May the 9th. And both of these are really popular. I think Spring Astronomy Day is being organized by Wing, and it's at Assiniboine Park and a bookstore. Assiniboine Park. Okay, so there'll be more information about it, but that will need people with telescopes to show the public what's up there. Hopefully it's a nice day. Science Rendezvous, again, Saturday, May 9. There's a pretty regular outreach to a daycare, which turns out to be quite an interesting event because young kids are pretty knowledgeable about, some of them know a lot about the moon, about stars and dinosaurs, and sort of all kinds of things come up. And the talk is at a fairly young level, but the questions are all over the map and it keeps things very interesting. And then there was one more thing on the bottom of this, which was the public event for Spruce Woods, which is August 22nd, I believe. Sorry, it just doesn't seem to want to fit on this slide. But it's a ways off again. That usually means some members go out with telescopes and there's a talk so that and then we show the public who are there the sky once the darkness falls. So those are the announcements. Was asked also to say something about some equipment that Sylvia Graca has for sale. Sylvia's in the middle of the theater. You can see her at the break and see what kind of goodies she has that you might be dying to buy. Now we're pausing for what's new, what's up and what's new, a little bit of both with Jay.
Okay, let's see if I can find this here.
Just go forward.
So what do you
do?
close that program?
Didn't you put it in the main?
Yeah, it's all in the main.
Oh,
Should all
okay.
be-
Yeah. Oh, there we go. We'll have to start up screen sharing again.
This sharing.
Here.
Hey. Until they would get it.
Right. February, March, we're sort of getting into the deep winter galaxies at this time of year. One of the things, quite an interesting object for those of you who have sea stars and dwarf telescopes, which are getting to be so popular, is to try this little fellow. This young lady, the Witchhead Nebula, which is right beside one of the brightest stars in the constellation of Orion, and that's why the upper left has a very bright corner there. That's because that is where the star is. So if it's a bit of an easy thing to find and a very difficult thing to photograph. So what's happening for the next month? We've got a total lunar eclipse coming. We're starting to see Venus. Gail promised you all kinds of exciting things. A little late for Valentine's, I guess, given Venus's reputation. But as they say in MASH, Wiggins, we saw that episode last week. Anyway, we've got all of the planets that have been behind the sun for the last little while are starting to come out from behind it now. And of course, since they're all coming out at approximately the same time or are on their way into it, depending on which one, then they're starting to gather together into getting our nice little conjunctions that come along when that happens. We got the quarter moon passing through the 80 star cluster again later this month, and that's always a challenge. Last time it happened 2 months ago, it was a full moon. This one is a quarter moon, which might give the photographers a little bit more. And although it's a little early, there's some speculation about a bright new comet coming along. So we'll take a look at the solar cycle for starters. We seem to be in a bit of a pause on the descent of the solar cycle in here. We're on, you can see the predicted pattern, and it's put a pause into it as well, which is good because there's been some rather nice aurora recently, mostly cloudy, it seems, when all the good ones are around. But it just means that our opportunity for decent aurora is still going to go on for some time. We don't actually hit minimum till 2031, but we're certainly going to be on the decline in the number of sunspots, although the activity level of the sun doesn't decline as quickly as the number of sunspots. We look in at the current sky in 9:30 in the evening. Looks like this. You can see we've got a piece of the winter Milky Way that's coming up in the southeast in the evening. We got Orion, which is almost due south through the evening sky, and even more next month. So this was prime time for Orion, and if you want to try that Witchhead Nebula, it's right down on the corner beside Rigel here. It will be a challenge for those of you with the sea stars, but I expect somebody will rise to the occasion. You just have to point it at Orion and turn on your little camera and let it do its own thing for the night while you go to sleep. A month from now, March 14th, you can see the winter Milky Way is now due south. Orion is starting to shift off over toward the southwest. But more important, we've got other things coming up over in here in Leo. And well, it doesn't show up on this chart, Virgo right behind it. So in that area, particularly in Vigo, Leo, you can see we have 6 pretty bright galaxies within that little area, including one known as the Leo triplet, which is 3 galaxies together. 95, 96, 36, 28, and 65, and 66 is another pair of galaxies. And they're pretty easy to find. So if you just take a telescope and scan in that area, they're pretty small. I'm not sure that a sea star will be able to do very much with them. You'd need a bigger telescope to photograph them, but the telescope at Glenley that we all have access to will certainly be something that would show those galaxies out very nicely. And that's a forerunner of what will be coming in April and even into May, when the Virgo cluster of galaxies moves into more prominent part of the evening sky. Just before I go anywhere, I talk a lot about things like M67, M65, NGC, this and that. So I thought I'd just, for those of you who are new, just tell you what all these things are. And what they do is they refer to catalogs. So Messier was the first catalog, and one that we use an awful lot here because it's got 110 of the brightest objects in it. And we give you a certificate and a pin if you complete the observation of all 110 of those objects. And I know a few of us have them, like Gail and Stan, I think, folks have Messier certificates, and I don't know who else does. It takes time because you've got to find them over the course of a year and draw them and or somehow record them. Then we have this catalog by the Herschels, William and his sister Carolyn, and then his son John expanded it mostly into the southern hemisphere. You can see there's quite a few 2,500 objects in there, and then 5,000 after John's update. So Messier object, you get an M in front of it, so M67 will be the 67th object in the catalog. And for the Herschel catalog, it's got this little H in front of it. We don't use that very much, except that we also have a certificate for 400 brightest Herschel objects. And so you can get that as a certificate, and that's a lot more challenge. The NGC catalog is used very widely, and you see what its history is here. It's continuously being updated, and part of that update is called the index catalog. So you'll very commonly run into the M catalog, the NGC catalog, and the IC catalog if you're using a computer to show you where things are in the sky. And generally, as you go from Messier to NGC to IC, you're going into fainter and fainter objects. And there are a lot of other ones, revised NGC and a revised NGC IC, and even a more recent one that's been revised in the early 2020s, mostly by amateur astronomers, because a lot of these catalogs have small errors in them. Planets, you can see that Mercury is coming out in the evening now. It should be starting to be visible any night now if you get there very, very quickly after sunset while the sky's still bright. That's not going to be along forever, because once we get past the 22nd, when it's at its best, it's going to be going back toward the horizon. And March is going to come out again on the other side of the sun. So Mercury, like Venus, is both a morning and evening star. Venus, I started looking for it tonight on the way here, but probably waited a little too late. But it should be coming out very, very bright in the west fairly shortly, within the next few days. And then it's going to be a very nice object in the sky for several more months, up until September. Mars is still in the sun. It comes out in March, but it's too low down. It's just sort of skipping along the horizon, so it probably won't be very good for us for at least another few months. Saturn is fairly easy to find now, but it's sinking down toward the horizon. Next month, it's going to be gone as it gets into, or not gone necessarily, but so low down that it'll have a poor view of it. So it doesn't get into the sun until toward the 25th of next month. Uranus is up for most of the early part of the morning or the evening. And then next month it's heading into the sun, and Neptune, as you can see, is close to Saturn. The two of them are coming close to each other now, and then they'll start to separate again. It's not really that bright enough, but it makes, if you can find Saturn, it makes it easy to find Neptune. And then it's gone after the month is over. So here we are at February 19th. That's probably the best show you're going to get. So you're going to get 4 planets and a crescent moon here. And so here they are. We've got Venus at the brightest one, Mercury up above it. This is for the 19th, so it's coming up fairly quickly. Saturn should be visible. Neptune will be harder to see, and the moon. So picture with 4 planets and a lovely crescent moon in it. If it's clear on the evening of the 19th, I put this picture in from 6:30 in the evening. it should be rather a lovely conjunction, or at least collection of planets with the moon. We have a lunar eclipse on March the 3rd, and it's visible here. The lunar eclipses occur when the sun and moon are at opposite sides of the sky with each other. And that occurs when the sun and the moon are both close to what is called the node. The node is where the moon's orbit crosses the ecliptic, which you could sort of think of as the sun's orbit, certainly the sun's path in the sky. So as long as they're close to that point, their shadows will line up and you get an eclipse. You can see that during the eclipse, the moon is a little bit past the node itself, but still close enough to be an eclipse. And for that reason, the moon passes through the bottom of the Earth's shadow called the umbra. That's the dark part of the shadow where no sunlight falls on the moon, and the penumbra, which is where, if you're standing on the moon, part of the sun is still visible as a crescent over the Earth's surface. And so it's not as dark. So you get the 7 stages of it here, and the timing for each one of these. And of course, Mother Nature is not always very forgiving, so just put this thing starting at 2 in the morning. But if you poke your head out at 5 o'clock in the morning, you should be able to see it in totality, and you just put your glasses on, grab the binoculars, rub your eyes, take a look, and go back to bed. It's only a lunar eclipse, except I know some of you will be out there probably looking for a nice horizon. It's going to set while it's still in partial eclipse, 7/17. And so that could be very nice to have a partial eclipse of the moon just above the horizon. You have to find the right trees to frame this or something like that. If you're a photographer, photographing a lunar eclipse is actually quite a difficult problem, because if you want to see the shadowed part of the moon, then you're overexposing the sunlit part. And if you want to see the sunlit part, you don't see anything at all of the. So you have to take your software and put those 2 pictures together, and you come out with something like this one. When I first did this picture, there was a band of blue that I couldn't get rid of between these 2, but after a lot of processing, I found a way to do it. And it turns out that that blue is real, and it should have been left there, because what it is it's lights that's passed through the upper levels of the Earth's atmosphere where the ozone layer is, and it gives it a blue color. So one of these days, I'll go and put the blue back in. This is something I did many, many years ago on film, where you just open the camera and let it stay open for 6 hours. And what you do is you get a picture of the moon as it gradually goes into eclipse. Can't see the red part in there very well, but it is there. But I think somebody could probably duplicate this with just rapid exposures frequently through the whole eclipse, and then put it all together in essentially not a star trail, but a moon trail, and see what comes of it. It'll be a lot of work, because it's not just opening a camera and waiting for 6 hours. In fact, I'm actually amazed that picture came out at all. The zodiacal light is out still. We talk about this twice every year, but March is the season for it, the first 2 weeks of March. And what this is sunlight that's reflected off of dust that's in the plane of the Earth's orbit. So you're basically looking at dust that lies along the zodiac, which is the path of the sun in the sky. And it's about as bright as the Milky Way in a good dark sky. It's quite easy to see, but you have to sort of know what you're looking at and not mistake it for some kind of light pollution, something like that. There's a little movie I shot of it a number of years ago, and you see it cycling back and forth. Pleiades are setting up above it, but it gradually fades away as the sun gets lower and lower in the sky. So the sun itself is just down in here. It was taken in Arizona some years back. More moon passing through the Pleiades. There's an opportunity to see a few occultations in here. Challenging photograph, but you could do the same thing like I mentioned for the lunar eclipse. Take a short exposure to get the moon exposed properly and long exposure for the stars, which are pretty bright, so long exposure probably only be about 1 second. And then you can go into your manipulations and put them together to come up with something. Or you could turn on your planetarium program and get this, and you don't have to even go out and look at it. But that's not what we do. So we have this new comet, C2025 A1. I think that must be C2026. Anyway, January 13, it was discovered. It's going to pass perihelion in early April. So at a little after the end of what I normally do in these talks, or cover it again next month. It's what's called a Kreutz family sun grazer, which means it passes very, very close to the sun's surface. And when that happens, and if it's the right kind of comet, this is a fairly big one, I think about 1.5 to 2.5 kilometers in size, then it starts to boil off all this stuff from the surface, and you end up having spectacular tails if everything else goes right. And of course, with comets, there's a lot of things that go wrong. The unfortunate aspect of this is that it's not well positioned for us. Here we are, picture, the comet is here. This is the sun is just barely set. It's down here in this image at 8:09, and this model is for 8:25. And from April 6 to April 10, the comet moves from here to here. It's expected to be visible for only a very, very short time. And when you look at the light curve of this comet, it goes along like this, and it just goes like that in a 3-day period. So if the comet has a tail, the tail will be pointing away from this, and past comets that have had similar sorts of passages from the sun have produced some of the most spectacular comets in the last century. So it's certainly something we'll be watching for from April 4th to about 10th. But after a few days, it will be too faint to see, and it's going to be pretty much too faint to see until it gets to its position very close to the sun. So there you have it for the month. This is the what's new that's coming up is this comet, and my wife told me not to get carried away and take too much time here. So we'll finish off with a picture of the Pleiades, which I'm waiting for somebody with the sea star to come up with something like this. Should be able to do that with a few hours of exposure. So thank you.
Thanks very much, Dave. Now we'll hear James Fast. For those of you who are not familiar with what we're calling show and tell or astrophoto corner or something, that's an opportunity for any member to give a short talk about just about anything they would like. Oh, somebody can't hear me.
So we have a little bit of problem with the.
Can you hear me now?
No.
No?
No problems. I'm sorry. I just need to just momentarily.
There you go. So the show and tell or astrophoto corner sections of meetings that you'll see once in a while are designed to allow any member to give a short talk on essentially anything of interest. The moon, the planet, some planet, particular method, a particular piece of equipment, how you found a problem and got out of it. You know, it just gives a little more variety in the meeting, and I think serves to educate most of us about something. So while we figure out some issue or other.
Sorry.
There we go.
See, what if you try to. There you go. Good.
Not sure what's,
What people were seeing wasn't what we wanted. It was all, it
oh,
was good. Yeah,
okay,
they look fine here.
so over to James.
Yeah, that's good.
Doesn't want to go forward now.
Session.
Just the click. To go through all of it.
You want to go through all of this?
Talk real fast, Gail.
You mentioned we have new technology.
Mine never came up.
Okay, we're almost there. Show and tell.
Okay. Am I on?
Should be.
Hello, hello, can you hear me? Perfect. Good evening, everyone. My name is James. And I just wanted to share with you one of my favorite activities in astronomy. There are many, and I call it observing the dance of the Galilean moons. But first, let's talk a little bit about Jupiter itself. Jupiter is the largest planet in our solar system, about 11 times the width and 5 times the distance from the sun as Earth. Jupiter's orbit around the sun takes almost 12 Earth years, so a year on Jupiter has 4,333 Earth days. However, a day on Jupiter is less than 10 hours long. So on Jupiter, a year has 10,476 days. That's a long year. So far, 95 moons have been discovered orbiting Jupiter, and the 4 brightest were discovered by our friend Galileo just over 400 years ago. These moons are named Io, Europa, Ganymede, and Callisto, and they're quite bright, ranging in magnitude from 4.6 to 5.6, and are easily observable with binoculars or a small telescope. And, I didn't actually know this, the Galilean moons are tidally locked with Jupiter. Oh, and by the way, for this presentation, I was going to use a picture of Jupiter taken by the Hubble Space Telescope, but frankly, Mike's images are better. Thank you for sending that, Mike. I think from Curacao, right? You sent that? Thank you very much. There'll be one more a little bit later on. So, Io is Jupiter's 3rd largest moon and orbits the planet in a little less than 2 Earth days. At an average distance of 442,000 kilometers away, Io is the closest of the Galilean moons to Jupiter. Io is volcanically active, the most active moon in our solar system, and is slightly larger than our moon. And in December 2023, the Juno spacecraft flew within 1,500 kilometers of Io's surface. Jupiter's 4th largest moon is Europa, and the 2nd closest of the Galilean moons to Jupiter, with an orbit of 3.6 days at an average distance of 671,000 kilometers. Europa is a bit smaller than our moon and shows almost no impact craters, suggesting it is geologically young and appears to be covered in salty ice water. In September 2022, Juno passed within 355 kilometers of Io's surface. And on October the 14th, 2024, the Europa Clipper mission was launched to determine if Europa has conditions suitable for sustaining life. Scheduled to arrive in April of 2030, it will orbit Jupiter and conduct 49 close flybys of Europa. Mighty Ganymede is Jupiter's largest moon, 1.5 times the size of our moon, and the largest moon in our solar system. Ganymede's orbit is 7.2 days, on average just over 1 million kilometers away from Jupiter. Ganymede has a lower density than Europa and Io, suggesting it is largely composed of water ice. The Galileo spacecraft detected that Ganymede has a magnetic field, the only moon known to have one. And Hubble has detected ozone, leading to thoughts of a slight oxygen atmosphere. Interestingly, Ganymede is in a 1 to 2 to 4 lap resonance with Europa and Io, meaning each time Ganymede orbits Jupiter, Europa orbits twice, and Io orbits 4 times. Callisto, I call the lonely Galilean moon, has an orbit of just under 17 days and is almost twice the distance away from Jupiter as Ganymede. Callisto is slightly smaller than the planet Mercury and is Jupiter's second largest moon, with a thin atmosphere of carbon dioxide and may have a salty ocean beneath its surface. Multiple spacecraft have visited this amazing world, including the in-progress JUICE mission, looking to further explore Jupiter's ocean-bearing moons. NASA's Galileo spacecraft transmitted these images of the Galilean moons back to Earth. The top row shows their correct relative size to each other. The middle row, these images have resolution approximately 1 kilometer per pixel, and we can see some of the volcanic lava fields, black spots on Io. We can see cracks in Europa's ice, and the bright regions on Ganymede appear to be cut into the ice crusts by tidal forces. And the large impact basin on Callisto shows ring-shaped characteristics. The bottom row are views with details of only a few tens of meters. On Io, we can see individual vents from which volcanic gases escape. Individual ice ridges typical of Europa, as well as rugged, stretched, and furrowed terrain on Ganymede and heavily eroded craters on Callisto. Well, if that wasn't interesting enough, what actually makes this so much fun? Well, as the Galilean moons orbit around Jupiter, sometimes they pass in front of or across Jupiter's surface. We call this a transit. Often the shadow of the moon is more easily seen transiting the planet as well. Here is another image that Mike sent to us that shows Io and its shadow. Here we can see, does my pointer show up there? Well, there's Io and there's its shadow kind of right behind it right there. Notice how Mike even captures some surface detail right on Io itself. Simply amazing. Now, a jewel of the Galilean transits is multiple transits at the same time. This is an image that I just took out of Stellarium back from January 2015. And here we can see lots going on. First of all, we see, I'll put my laser pointer on, be better. Here we can see Europa having yet starting to cross over in front of Jupiter. And we see Europa's shadow right over here. There's the shadow, there's Europa, there's the shadow. Having already started to transit across Jupiter is Callisto right here. However, Callisto's shadow is way over here. And then here, just about ready to finish transiting across Jupiter is Io, and its shadow isn't there. Any thoughts on why Europa's shadow is so close to Europa, but Callisto's shadow is so far away? Anyone? Distance, right? Callisto, remember, is the lonely Galilean moon further away. So it's further away from Jupiter. Well, it gets better even yet. As the moons pass behind the planet in their orbits, from our view, they are covered or occulted by Jupiter until they eventually reappear back into view. Now, just like other objects out in our solar system in space, Jupiter blocks sunlight and casts a shadow into space away from the sun. When a moon passes through a planet's shadow, Jay kind of talked about this, we would call that a what? A moon passing through a planet's shadow? We'd call that an eclipse. And the best part is as Jupiter and Earth orbit the sun, the relative angle of that shadow changes. And we actually get to see the shadow and these eclipses. Watching a Jovian lunar eclipse is spectacular. Our little friend Callisto is right there, but we can't see her. And we get to see one next Friday night. So if you're available and it's clear and you want to come out to Glenlee and join us, we're going to try to watch this. So I've simulated it here using Stellarium. I've sped this up a fair bit. Watching it in real time actually goes quite a bit longer. Right after sunset on the 20th, Callisto and Io are next to each other, separated by about 15 arc seconds. You'll need medium power binoculars or a small telescope to see that. Watch as Io slowly moves towards and in front of Jupiter, and Callisto, having been just behind, come out from behind Jupiter, is moving away from Jupiter. See how long it takes for you to be able to resolve Io separately from Jupiter with your binoculars or your telescope before it winks out and starts to transit across Jupiter's surface. Right after about 8 o'clock, Jupiter's shadow, oh, sorry, lost my spot here. As we approach 8 o'clock, keep your eye on Callisto. It's going to disappear into that shadow behind Jupiter. Now, remember, I've sped this up a little bit. In real time, that takes several minutes. In fact, Mike, I'd wager that you could image that shadow moving across Callisto's surface. Now, we'll watch this a little bit. In fact, I might speed this up more if I can do that. Turn that off. So here we have the shadow. And there's Io right over there, transiting across. Now, just after 9:30, Io completes its transit across Jupiter and slowly becomes more visible again, popping back out from across on Jupiter's surface. And Io follows along, slowly moving its way across. Okay, now I'm going to speed this up a little bit. I'm going to turn that off and move this up. Okay, so now we're just going to kind of be watching this. Oh, we're also, as Io and its shadow finish its transit, we can see the GRS starting to come into view here, so we could watch that a little bit. But over the next hour or two, Io and Europa start kind of making their way towards each other, coming slowly, getting ever closer and closer and closer and closer. We're now getting to be about midnight. So as midnight begins to approach, keep your eye back up here in this top little corner over here. Remember our little friend Callisto? Still in being eclipsed by Jupiter's shadow, is going to pop back into view. Again, that will happen in real time. That will happen over a minute or two. Actually, last night, Io did the same thing, much closer to Jupiter, and the fog lifted in time for me to go out and watch it just in my binoculars, and that was a lot of fun. And then as the evening continues, we can see Io and Europa slowly kind of move their way back close together, and they almost looks like they touch. In fact, they get within about 6 arc seconds of each other. So, Mike, what do you think? Is that doable? Yeah. In conclusion, watching the dance of the Galilean moons can be done really with any kinds of optics. You can do it with binoculars, even low power binoculars. You can see the Galilean moons. Probably mounting them is best if you can. You can use a small or low power telescope. If you want to watch the actual transits, especially the planets, you're going to need a larger telescope, probably 6-inch or larger, and some good magnification, and of course, our worst enemy, good seeing. And it's a good resolving power test of our optics, including our eyes. Early in the evening, Io and Callisto start. They're about 15 arc seconds apart. And then at the end there, I showed Io and Europa close to 6 arc seconds apart. Can your binoculars split 6 arc seconds? Now all we need are clear skies. And thank you very much. Oh, look, you turn me back on me real quick. I think there's a break coming up. Is that next, I believe? I do have 2 calendars left. The RASC calendars, they're $20 each. So if you have cash or you can e-transfer the club, you can come find me. I have them right over here.
Okay. So thank you very much, James. That was interesting. We do have a break now. It's 8:18. So we'll break until 8:40 or so, 8:30. And then we'll have our main speaker talking to us about auroral citizen science. Okay. Right. It's good to meet you. Yes. Good to meet you. Nice to meet you. He's watching that song.
Is that okay, the way?
Yeah,
Okay. I'm very excited to be here, and so what is citizen science? Another word for it is participatory science. So it's many things, and I'm going to talk to you about all of the different things that I do as a citizen scientist. And one thing I just want to let you know is that this is all volunteer work. I don't get paid for anything, any of this work that I do. It's all volunteer. I don't get paid for any of the photos that I contribute to science, but I do get what we call reciprocity. I get something in return. They are teaching me about the aurora, or I am given trips to participate in workshops here and there, etc. Or I'm supported and promoted. They promote my photography. It's very rewarding to do all of these things together. And I've divided my citizen science activities into about 9 areas. So either places that I've gone to or projects that I'm on. So I'm gonna start with the taking the photos. I wanted to ask, is anyone else here an auroral photographer? Awesome, that's wonderful. I was going to ask if anyone had an interesting story about the aurora, but I realized that people online wouldn't be able to hear you, so we'll have to skip that and carry on to my photos. Okay, so the first section I'm going to talk about is some of the aurora photos that I have taken over the years. I've been taking aurora photos for about 11 years. And did I miss a slide?
Yeah.
I did. Where is it? Okay, it's gone. Okay, the first time that I took aurora photos was in September of 2014. And the first time I got my aurora photos focused was March 17th, 2015. Does anyone else remember that storm? No, it was an incredible storm. So that's the first time I was able to get them focused. So that's where I started. So this storm was just this last fall, and it was a very colorful storm. This is the second night of a 2-day storm, and we had just as the auroral storm was breaking, we had this beautiful curtain above this barn. And this is one of the shots that I got. One of the things that the scientists want to see is the magnetic field lines in the big storms. So this definitely shows magnetic field lines. Okay. So this was the first night on November 11th. Did anyone see the red aurora on November 11th? Yeah. It was incredible. I never see any of the color with the naked eye. I can only see what the camera tells me is there. But that night I was able to see the red aurora with the naked eye, and it was mind-blowing. It was just so beautiful. This is another big storm, and a spiral is a really beautiful thing to see when the aurora is dancing. And this spiral is directly above me, and you can see the vortex in it. You can see the cone shape as above the spinning vortex underneath, and it was a beautiful thing to capture. Oh, I'm going backwards. What else can I click here so that? Okay, well, I'll just try and do better.
There are these direction.
Okay. Okay.
Is that okay?
Great. Yeah, perfect. Awesome. Okay. The next thing was, this was a night of aurora that I took photos for about 6 hours, and I got some proton aurora. The best time to catch proton aurora is early in the evening. And I was ready when it got dark to catch the proton aurora. So you can see the blue-green proton blobs, and it's just south or just on the equator side of the main aurora. And it would be in the ring current, if you know what that is. And this night we had an incredible SAR arc, stable auroral red arc. These red arcs can last for hours, sometimes days. And I took photos for about 6 hours that night, and it was there the whole time through the different phases. It did morph from one thing to another. And you can see that this is right after dusk, that the setting sun is just on the, just shutting the lights out for us. And that arc did morph to maybe a double or a triple arc. Maybe it was a Steve for a little while this beautiful curtain was to the north of me. An omega band is a very interesting thing to capture, but you don't see these until after magnetic midnight. Now, the omegas are open to the north or to the polar side. And on the equator side of the omega band, there's this pulsating aurora, and that is very faint. But I had gone to bed around 10 o'clock and the aurora wasn't dancing, but I knew it might. So I woke up at midnight, looked out, and I saw that there was aurora. So I grabbed my gear and caught this beautiful bright omega band. And you can see in the top corner, I found a satellite image that matched what I was taking photos of. If I'm capturing photos after midnight, I usually go to an imagery viewer online and see if there's any pictures of the aurora that I took, because those satellites make a few passes between midnight and dawn. Now, these little tic tacs are called auroral fragments, and they're very difficult to find. This is one thing that auroral researchers are studying right now, and they are called fragmented auroral emissions. I just got an email from a researcher in Svalbard, and she is just about to submit a paper on the fragments. I think this might be the first research paper on auroral fragments, and she's using one of my observations. And out of the 10 years I've been taking photos of the aurora, I've only caught them twice that I can tell. And both times was just before dawn. This was probably at 6 a.m. It was an all-night aurora, and I finally had to go in at 7 a.m. to get ready for work. So. Now, these things are the auroral dunes. They are finger-like structures that point towards the equator. They're not easy to see. And you usually have to turn your camera to the east or the west, because if you're looking directly north at them, you can't see them. They're an elusive things. And one of the researchers I'm working with, he's just submitted his paper using this observation just before the end of December. He submitted his paper. And the auroral colors are very fascinating. I was when we were at one of our meetings, this researcher, Mathieu Bartholomé from France, was studying auroral features, the colors of the aurora with a spectrograph. And he was looking for a thin curtain, a single curtain of aurora. So I gave him a few of my pictures from this night because it was a beautiful tall curtain of color. And he sent an email last week. He's just submitting his paper using a few observations, and one of them was this one. Auroral beads are something. Has anyone noticed auroral beads just as the substorm is at onset, just about to dance? This is what you look for, is auroral beads, those vertical stripes just before the curls start, and then it starts expanding. Has anyone been up north to see the aurora?
Yes.
Now, there's nothing like seeing the aurora under the oval up in Churchill or Yellowknife or Fairbanks, Norway. And it looks different in pictures. You mostly see that bright green arc. There's tons of colors up there too, but usually the green is so bright that that's what stands out. That's what the cameras are set for. And this was in Churchill. Now, the Gannon superstorm, or the Mother's Day storm on May 10th, 11th, 2024. Did anyone else catch that one? Yeah, that was an incredible storm, and it had gone so far south. We just saw a lot of bright aurora. We did see some discrete arcs throughout the substorms as it expanded, but the south edge of the oval was so far south, that's where the dancing started. This is one of my favorite photos, and it is very little features in it, but it had such bright color. And the last thing I want to show you is the Steve. Has anyone here captured a Steve? Awesome. Steve is, I've captured the Steve probably over 30 times. And this one was the most massive Steve that I have ever seen. It was August 29th, 2022. And this image is taken with a 20mm lens. I was looking north and straight up. So you can imagine how much sky I'm capturing. It was absolutely massive. Usually a Steve is a narrow mauve band, but this you can see the deep red on the top, the mauve in the middle, and the white on the bottom. And then there's the pickets and the streaks underneath it. This is one of my favorite pictures ever. So there are some of my pictures. Now, how did I get started in citizen science? When I started taking photos of the aurora, I wanted to find a community to connect with, and I found them on Twitter. And one of the organizations that I connected with was Aurorasaurus. They would advertise on Twitter for people to report. And in I think it was 2018 or maybe 2019, they were asking if there was anyone interested in becoming an Aurorasaurus ambassador. So I applied and went through the application process and was accepted as an ambassador. And I have been meeting with them monthly ever since that. We meet on Zoom. So right through COVID, we had something to do online on a monthly basis. And I learned so much. Dr. Liz McDonald, she has taught me so much about the aurora. I was so inquisitive and I wanted to learn so much about the features, and she taught me so much, especially when it came to reading Dr. Akasofu's paper, Development of the Auroral Substorm. Now that was a game changer for me to understand the auroral substorm. So I knew what to watch for in the sky. Instead of just the data, you can watch in the sky and you can tell what's going on. So that was a game changer for my aurora chase. Their website is amazing. I'm going to talk a little bit more about Aurorasaurus later, but their website has some incredible stuff. One of the things that they have given back to me in reciprocity is that they have encouraged me and given me opportunities. So in 2020, when I was out photographing the comet Neowise and the aurora, I caught a meteor slashing through the handle of the Big Dipper, and I also caught a faint little Steve way to the west. I was so excited about capturing that picture, capturing all of those together. And I think that purple thing, it's some type of an arc, I'm not sure what it is. Dr. McDonald thought it may have been a second Steve, or maybe it's a SAR arc, I don't know, but it looks like it's separated from the main aurora. It's not part of the green. So she contacted me. I posted the picture right away on Twitter. She contacted me and says, can we send this picture to NASA Explorers and see if they can pick that up as a feature? So they contacted me, and I told them about my experience, and they posted the picture. So I've got QR codes on my on the presentation. I do have a sheet of the QR codes later if you want to see the different websites and articles, etc. And so that was posted on NASA Explore 2 days after I caught it. The next time, when I had captured black aurora for the first time, didn't know I was capturing black aurora before. I thought it could be when I was seeing the strips. But when I got home from taking these pictures and I saw those teardrop shapes, I knew I had caught black aurora, because that is one of the textbook signs, is those teardrop shapes. So when I did my report in Aurorasaurus, I used that photo and said, this is black aurora. And when it came time that NASA was looking for a photo of black aurora for an article in January of last year, they contacted me if they could use that in the article. Okay, now word number 3. I was approached, once I started reporting the auroras and getting to know the worldwide community who was studying the aurora, I was contacted by Dr. Maxine Grandin from Finland to see if I'd be interested in participating in a research project, a 2-year working group through the International Space Science Institute in Bern, Switzerland. And it was called Arctics, which it stands for Auroral Research Coordination towards internationalized citizen science. So this is right up my alley. I was pinching myself for 6 months after I had been asked. And we started meeting in September of that year. The first physical meeting in Bern was in January of 2024. I wasn't able to go. Our son was getting married, so I couldn't go that week. But I was able to go to the meeting in June of that year. So in January, we started collaborating together online, all of us from around the world, collaborating on a document, a handbook for citizen science. This was one of the goals of the group, was to create a handbook for citizen scientists, for scientists to collaborate together, information that they could be used, and it would be a free resource online. So when we met in June, I had been working with them online on this, and I said, what's really missing here is the pictures. I would, as a photographer, I would really like to see some pictures in this document. And one of the researchers, Dr. Katie Hurlingshaw from Svalbard, latched onto that idea, and she said, yes, we should create a field guide as well. So we decided at that point we were going to create a field guide using photos from the group, about 30 of us, whoever would be able to contribute photos for the field guide so that we could use them to identify the features of the aurora, and it would help us to communicate with each other, or to have citizen scientists communicate easier with the scientists or the researchers. So we had a big task ahead of us. This is all volunteer time. The scientists, of course, were working through the institutions that hire them, but those of us who are citizen scientists, this is all volunteer time. And I think I probably worked about 20 hours a week through the summer. We pushed really hard to get this done so that we could publish it in September, and we got that accomplished. So by the next meeting in May of 2025, we had it published, and Katie was able to get a little bit of funding so she could print us each a hard copy of the field guide. So there are a few hard copies of this field guide around, not too many of them, but it was a real thrill to have that done. So these two items are published online. They're free resources, and we encourage anyone who's interested in science, citizen science, to go online and use them. They have been used around the world, and by December 2025, our project was complete, and we had 7 peer-reviewed published articles. So we weren't just doing the handbook and the field guide, we were doing research as well. So we had 7 articles that were published. We had 2 in preprint, and I've just heard of 3 more that are just about to be submitted. So we do have plans to meet again. We have still a long list of things that we've started and want to accomplish. So someone that in the group is working through, I can't remember which university in Brussels. So they said that they would host us this year in Brussels, and then we have applied again for another project through EC. This way. The next one, number 4, Solar Max mission. Now that was something that I got connected to through the group in Arctics. Katie Hurlingshaw was approached by Janneke Mikkelsen so they both lived in Svalbard, And Jannica was a videographer in Norway. And Katie was a researcher. So they got together and applied for funding for a project that they were going to call Solar Max Mission. And this would be polar orbit. They were applying to SpaceX to do a polar orbit around, I don't know how many times. So this would be a 3 to 5 day mission, doing polar orbit and taking photos and videos of the aurora as they orbited, as the Earth rotated. And from the ground, we would coordinate people taking from the ground at the same time as Fram 2 was passing over. So we didn't know when this was going to happen. Once it was accepted in the same September that we published our handbook and field guide, Katie was told that this project was accepted and that she was told when it might fly, but they were very secretive about when they might fly. So we just were told a week before Fram 2 was going to fly at the end of March. They launched for our time, it was the night of March 30th, and they would fly for 3 days, 3 or 4 days. And so it was a bit of a scramble at the start. And there's a picture I have here of our field guide up in space. That's pretty cool. It's Jannica is holding the field guide in the cupola where she took the images. So that was very exciting. So we are still waiting for SpaceX or whoever to release the images to the mission team so that they can compare. But I saw a video that Jannica said that they got the images that they were looking for. They were looking for continuum and fragments. So I was in a group of 4 women in Manitoba. So there was people from around the world, but in Manitoba, there was 4 of us that really wanted to capture the images for the project. So we drove north of Dauphin that night where we thought would be best to be away from the clouds. We didn't have a good night the night before. We had total clouds, but on the 3rd, we had some clear sky. So just as it was getting dark, the aurora was starting, and we caught Fram 2 above that church. We drove around looking for a place to stop, and we found this church. So we thought we would park there and take photos. So it was pretty exciting that we were able to catch Fram 2 flying above us. We knew approximately when and approximately where it would be flying over. And each orbit would take an hour and a half. So after it passed us, an hour and a half later, it was over top of Alberta when it passed. And just as it went above Alberta, we think we were still in their field of view. And that's what happened. We had a substorm onset. So there was beads and curls and dancing and expansion, and we saw a star arc. I think probably by the time the star arc happened, they were probably way over the southern hemisphere, but we saw some good aurora. So we think that when they were over Canada that night, they probably got some good footage. And the next thing is the aurora eye. Now I brought unit 15 with me, but the first aurora eye that I was able to use was unit 5. That was one of the oldest units that Jeremy has. Jeremy is the owner, and he's also citizen science. I work with him in Aurorasaurus, and many other projects, Arctics and Steve Workshop, etc. So these are portable all-sky cameras that are an amazing thing for a citizen science to use. I take I turn the device on, it takes photos. I have mine set, I think, for about 5 seconds, ISO 1600. And so it takes a series of photos. When we're done, we take it home. I connect it to Wi-Fi and it uploads the photos to online storage. Jeremy puts it through his software, creates a time lapse and posts it on YouTube. So that takes away the burden of data storage, data transfer, and processing for me. All I need to do is turn the machine on and it does its thing. So these are the images that we get through the all-sky camera, which is a round image. And this was taken on October 11th, 2024. This is an amazing storm. So Jeremy put this picture together for me, and it shows one image in the center, and it shows the kilogram around. If you know what a kilogram is, it's a slice of the picture. So it's a slice of every picture I took that night, and it's sandwiched in the ring around the image. And as you watch the video on YouTube, you can see the marker as to what spot in the night we're at. I've got a video here that I took on October 11th, and I'm just going to show you how this works. As you can see, I put the camera on when it was daylight because I went to a location 30 miles away. So it was going on daylight. So here, I'm just going to grab it and pull it. You can see that cursor moving along the kilogram. So that's where it is. And Jeremy is a citizen scientist as well. And he said he developed this because he had FOMO. He didn't know what was happening behind him when he was taking pictures that way. So he thought, let's do an all-sky camera. And being a citizen scientist, very dedicated to supporting science, he has built many of these units for use in science. One of the really cool things is you can, or several of the cool things, he's got the location, the GPS location, the settings for the camera, the time in UTC, the date. And if you grab the dot, whatever you call that dot, you can pull it up and you can see the images. You can move to whatever spot in the night you want to see. So this is quite an amazing tool, and it's captured some pretty cool things. One of the things that Jeremy was able to capture was a northern Steve, or a quiet time Steve, way up in Yellowknife. He's from Nova Scotia, but he does travel a little bit. He has lived in a few places across Canada, and he was up in Yellowknife, and he captured a Steve when they were saying, no, Steve doesn't happen in the north. It doesn't happen. It has to happen after a substorm. They proved that there is a Steve that happens without a substorm way up north, and he was able to capture it with one of his units. Okay, there we go. Okay, so I returned Unit 5 in March of last year. There were some glitches. It was one of his older prototypes. So he's just built a new prototype, and he just sent me Unit 15 for me to use. But this time I've got into more of a partnership with him. I purchased the camera and the lens and the battery that goes into it. So I own the camera and the images. Jeremy owns the unit and the license to use the images, and we still have that partnership where I upload the images and he puts them on YouTube. So I encourage you to go to Capture North YouTube channel and check out some of the images. He has used, he was asked, I think a year ago, by a planetarium in Europe, if they would, if he would put together a show that they could use in their planetarium, and it's being used there. And that video is on his YouTube channel as well. And he's done some amazing work, and it's great to work with him. The next thing is Steve Workshop. So I think most of you know what Steve is, the thin ribbon that happens at the end of the substorm cycle in the recovery phase. I was told that you had someone talk to you about Steve before. So Steve is still very much an enigma for many reasons, and they have started doing some Steve workshops. So in October 2022, they had their second workshop, and one of the researchers had asked me for some pictures of the Steve that I'd captured on August 29th, 2022, and he used a lot of them for the presentation. They streamed the workshop, so I was able to watch online. And it was, I think it was most of the week for Monday to Friday. I watched as much as I could. And then I was invited to attend the one in October 2025. Bea Gaillard-Lacourt invited me to go to the workshop. They had it in Alaska. So this was a 3-day workshop, and they had about 30 participants there, or maybe even more. And it was an amazing event. The science sometimes gets way over my head, but I try hard to understand it. You know, my contribution is the images, and I'm learning to see the features. And we had some great discussion, and we have moved forward in our understanding of Steve each time we meet and talk. So number 7 is contributing to publications and media and research papers. I do get calls once in a while, not very often. There's so many people out there that take photos of the aurora. There's many other people out there that they could contact other than me, but once in a while they come my way. And in June of 2022, Vincent Ledvina asked me if I would be interested in participating in a research paper that he was doing on citizen science. So there's the QR code for that research paper. And that was just another step in being a part of citizen science. This image was taken up in Churchill in end of March of 2022. And I was in a group of people. Vincent was there, and several other people were there, and we saw some amazing overhead aurora. That was before he moved to Alaska. And the most important thing that I do as a citizen scientist is report the auroras. This is again from that August 29th, 2022 event, and you can see I'm looking directly, this is a panorama image, but I'm looking directly east, so you can see that I'm right underneath the oval, or right underneath the Steve, and that's the best place to be to see Steve, because if you are too far north or too far south, it can be too faint to see. But directly underneath, and it was the most complex and massive Steve I've ever seen. So one of the 2 places I report auroras, I do contact some researchers who are researching specific things with some of my observations, but I try to, every event, I try to report to Aurorasaurus and maybe do several reports to Aurorasaurus. I can only do 1 picture. So has anyone here ever reported to Aurorasaurus? Awesome. That's exciting. I'm going to tell them. They were so excited for me. We had our Aurorasaurus meeting this morning. And so I have my own account. I log in, and then the first thing I do is I answer yes or no. Did I see the aurora? The no the no reports are important. If there's a big storm, they know that we should be seeing the aurora, but if we have clouds or a storm or whatever, they want to know that. So I do make no reports sometimes. If you want to look at past reports, you can dial in you can see on the right-hand side, there's a date and time. You can dial that in and see what the oval looked like and how many reports there were. So you just need to answer a few questions, do a little bit of a description of the event, and share a picture if you have a picture that you can put in the report. And the other place that I report to is Skywarden. And I learned that during the first Steve workshop, Emma Bruce was involved and she was talking about reporting to Skywarden. Now, if you Google Skywarden, you won't find it because it's in Finnish. So if you look at that red circled word, I'm not sure how to pronounce it, but it's Tevanvati, something like that. If you can Google that, then you will find the website. And again, I've got the QR codes for that. It's you can do a much more complex report in this because you're allowed to submit up to 8 pictures, or you could put videos in there. They do have a cap on the amount of data that you send there, but they're very they have an amazing website. It's run by URSA, which is the Astronomical Association in Finland. So you can report more than just auroras to this place, any type of astronomical phenomena. I've reported some of the comets I've seen, etc. Some meteors I've reported to them. And they don't get many reports from North America. Most of them are from Europe. Most of them are from Finland. But this is a place where a lot of the researchers go to say, okay, I need to do a search for fragments. And they can, within a few seconds, they can do a search for fragments, and all of the reports will come out and show them where fragments have been seen on a certain date and time, or just fragments in general. And number 9 is social media. So that's something that's how we connect to each other around the world and locally. And in 2020, I was invited by Justin Anderson to join Manitoba Aurora and Astronomy as moderator. And I've been working with them and supporting the project there. And I've made so many amazing Aurora friends through these groups, and starting with our one in Manitoba. And then in 2025, we were getting ready to launch the Solar Max mission, and an Aurora friend of mine and I decided that we should put together a Facebook group just for Aurora. And we wanted to do a strong focus on citizen science, on teaching people and sharing information. And it's just a small group, but we do we probably operate more like a page than a group. But we have a little chat where when we go out chasing, we chat together when we're out. And that's great encouragement. Do you see it over in Pinawa or up in Thompson or whatever? And we can chat together. And it's been very successful in encouraging citizen science. And one of the things that we did was last fall, when after the November 11th storm, a few days later, Aurora Source contacted me, Laura Edson contacted me, and she said, did you guys not see the aurora that night? Because we only see 4 reports from Manitoba. And I said, yes, we saw the aurora. And it's very difficult to get people to want to report. There's very few citizen scientists around. It's as I say, it's volunteer work. And a lot of people just want to take pretty pictures, and I don't blame them, because there's some nights I just want to take pretty pictures. Other nights I just want to see the whole sky and capture everything. So I have all my cameras going. But they wanted me to encourage people to to anyone who was willing to do more reports. So we posted on Manitoba Aurora and Astronomy and on Manitoba Aurora Chasers. We're encouraging people to do more reports. So if you can see this, the screenshot, the first time we only had 4 reports in Manitoba. And the second time that I did the screenshot, we had 27. So they, this is one of the things I do as an Aurora Source ambassador, is encourage people to do reporting so that the scientists know what was out there at the same, on those big storms. As you can see, the aurora was huge that night. The oval went way down south. So you might want to know what kind of gear I use. And my 2 main cameras are, right now it's a Canon 5D Mark IV, and I have a Sigma 14mm f1.8 lens on it. That's what I use for my main pictures, and for my time lapses I use a Canon RP, and I've got another Sigma lens on it. These are real bulbous lens, ultra wide lenses, and they're amazing lenses. I don't always get them focused right. I tried taping the focusing ring, but I have a notorious problem with focusing, but I am getting better. So, and there's other cameras that I use, various tripods. Those are the settings that I use for time lapses, and it's depending on how bright it is would be the other settings, but I have them doing at 1 second intervals, and I love to put time lapses together. These are the apps or the Aurora chasing resources that I use. I know that whoever wrote that email talked about Space Weather Live. So these are a few of the apps. I use several apps for different reasons. And the Aurora guy, Vincent Ledvina, he's an amazing resource. So I want to show you a few of my time lapses. This was taken last summer when we had noctilucent clouds and aurora. And I found a little pond that I could get a little bit of reflection. That night that I caught the comet Neowise and all the other stuff, there was noctilucent clouds that night as well. This was September 28th, facing east, so it was all night aurora. And you can see that when it expanded, it was just, we had the south edge of the main aurora above us, and there was pulsating aurora to the south. Now, on the one on the left, it is November 11th. The one in the center was, I think it was June 4th. I think that's the harangue reversal happening above me. It was something wild. That was right at magnetic midnight when the flow changes directions. And the one on the right is that Steve. I wasn't taking time-lapse photos, but I did take some series of photos that I was able to put together to make a little time-lapse. It's not great, it's kind of choppy, but it gives you an idea of what that event was like. And this was November 11th again. I was right at the north end of Riding Mountain, shooting with a friend, and these pictures are taken facing south or up. And you can see the field the magnetic field alignment. That's one thing that the scientists are looking for, is that magnetic field alignment. This is looking back towards Dauphin, as that red was coming back. It was mind-blowing color, and I had just come back. Can't remember where I was. I just come back from a trip. I was so tired I couldn't stay up all night. That was so sad. And I love comets. So this was Comet C 2023 A3 Atlas. I don't know how to pronounce that first part, but it was a beautiful comet. We couldn't capture it for very long, but it was so cool. And poor little Lemon got beat out by the the satellites this night. The Starlink train and all of the satellites. Oh. But yeah, that was wild. And that's what I do as a citizen scientist. I'm very grateful for all of the people and organizations that have supported me and encouraged me and taught me and included me in things. And there's way too many I don't know. I did name a few names in the presentation, but there's way more names than just that I am grateful for. So I just wanted to encourage any of you who might have an inkling to participate in citizen science. I just want to encourage you to do a report. It doesn't have to be a big report or a fancy report. You don't need to know all the answers to all the questions. Just start somewhere, just post a picture or just say, yes, I saw the aurora on any night that you may see it, or I didn't see the aurora, and you know that other people were seeing it. And you can check out our handbook and field guide. Again, I've got the links on a piece of paper here if you're looking for them. And if you have any questions or if you'd like to learn more, don't hesitate to contact me. I'd be happy to answer any questions you've got. Oops, no, I wasn't supposed to do that. So this is on the May 10th. 2024, the Mother's Day weekend storm. And I'm the one standing under the field lines. So that's all that I have to share with you. And if you have any questions. So, questions? Go ahead.
How or when do they encourage to post it? At the time of the event or when we come back, or basically the one close out?
When do you report?
Yeah. At the time of the event or you can do it later in the day?
That's a really good question. If my cell service was better, I would probably do more reporting out in the field, but I have really poor cell service where I am. I might do, I will say yes on the Glendale app that I have seen aurora, because when you have an app open, when you leave the house, you can still access it. But to do my reports in Aurorasaurus or Skywarden, I usually do Aurorasaurus the next day because it's only one picture. And then I usually go through my pictures and report to Skywarden a couple of days later. Once I've looked at I've got a good selection of different things that happen through the night. So you can report that night. They do like it if you can report that night. That helps them to alert others as to where the edge of the oval is, what you're seeing. And but you don't have to. So anytime you can backdate them to, you know, I can go and make a report from 2014 if I want to. So
It's great to know.
You're working pretty constant lately, or are there big spaces where, because you know, in the city, I don't get to see it as much.
No, we get so many clouds. It's been so cloudy. And last year was like, or 2024 was an incredible year when we hit solar maximum. It was an incredible year. And we had some really good storms in 2025. We had lots of clouds too. And we had, was it a week or so ago, there's a huge sunspot area was promising, and it did send some good stuff our way, but not as huge as we had anticipated. It wasn't earth directed, or I think we got an edge of it, but we didn't get the full blast of it. But Yeah, it's as who was talking about the solar cycle, we are on the downswing now, but but usually on the downswing, you get lots of coronal holes that send some great solar wind, so that doesn't mean the aurora is gonna quit. So it just all depends on what happens on the sun. And if like this, the coronal holes can be in the 28-day cycle, they can tell you, oh yeah, we're gonna get that coronal hole again, we're gonna get it again, so it's gonna send out some good wind to us. But the CMEs, when they happen and send out coronal mass ejection at us, we have about a 3-day notice. So yeah, you just have to follow I follow Vincent Ledvina and Space Weather Live. And some of my apps will give me alerts as well. And being in the groups, then you can hear the chatter and you know when it's a good night to go out. And it's always good to have an app that tells you when there's gonna be clouds too.
Unless it's 2 in the morning, so the classes 5 have to go back to sleep.
Yeah.
I have a question.
Yes.
Do you ever get feedback from the, the formal professional scientists about how your photographs, the data that you're sending, how they're being used? I know you mentioned on some of the papers they do, but do you ever get feedback about how the papers do, like with the other scientists, like what they've been able to prove or show or add to knowledge?
Yeah, it's collaborating with the researchers. I like to see immediate results, but for the science to happen, it takes a long time. So if I have submitted pictures directly to that researcher and they say, yes, there's something here that we can use, then I may have to wait for a year before they have completed their research. And the last 2 emails, they were offering me to be a co-author on their papers because of what I submitted to them. And then sometimes they invite me to participate in editing before they submit it. And when we were working in Arctics, I was on a few different papers, working with people on a few different papers, so that means we would have more collaborative time together to talk about the paper. Normally, I'm just a contributor of the pictures. So I submit it, I wait to hear if it's of any interest, of any significance, and then they run with it. And yeah, it's not it doesn't happen quickly.
Good science hardly ever does.
Yeah. Yeah.
Other questions, Mike?
Just wanted to thank you for coming and sharing your joy of doing this. I just was never aware that citizen science can be done with the work.
Oh,
Yeah.
oh, well, that's great. Well, you're very welcome. I would love to talk to people about the aurora, and this is a fantastic opportunity. So thank you so much for having me here. I'm very grateful.
Some other questions. I think Tammy and then Damon and then.
So what's your day job?
Well, Armin and I farm. We farm with our son and daughter-in-law, and we actually met exactly 45 years ago when we were both attending U of M. This on Friday, the 13th of February at an Aggie social. And it's awesome.
Well, as the day, I wanted to say thank you.
Oh,
And I can imagine the hours you put in doing this. And I just want to say thank you because I learned a few things about Aurora that I didn't know. And I grew up in Northwestern Ontario in a really dark area and heard them snapping over my head.
really?
Sky but I learned a few things that I wasn't aware of just by you naming them, so thank you very much.
Oh, you're very
And
welcome.
if my knees ever behave, I might get out there and do some myself.
Yeah, go on a night that's not so cold.
Well done, thank you very much for sharing.
Yeah, you're welcome.
Damon, do you have a question?
Yeah,
Mark's got a mic.
I guess it was September 2023, we were at our annual Sprucewood Star Party. And we had a huge aurora show, like it went probably 3/4 the way across the sky, past the ecliptic to the south. And I remember around 2 in the morning, it had just turned to green soup, so everybody went to bed, and then about half an hour later, it all resolved itself again. And me and I think the only one or two people were up, were listening to the crackling noises. And I know that's not directly from the aurora, but I'm just wondering how rare is that, because I've never seen that or heard that before.
Well, I've never heard, that was probably September 18th, 2023. Was it?
Could have been.
I think it probably was. That was an amazing storm. I have never heard it myself, and there's a lot of question about what you're actually hearing, and they they think it's something atmospheric happening at the time when the aurora is active. It's not actually the aurora itself. They think it's just something atmospheric happening. I've never heard it though. I hear when the aurora is in the pulsating phase, I can hear the power lines humming, and I've recorded power lines humming and with the aurora pulsating behind it. And I've recorded the coyotes because they yip too. But no, as far as the sound goes, I've never heard it. I would love to hear it. I've heard a lot of people way up north hear it. But yeah, I wish, if you didn't have that star party in Harvest, maybe I could come.
Yeah, so it was really beautiful out that night.
Yeah.
And then a week later, there was another set.
September 28th.
Yeah, there was just beautiful set.
Oh.
So one of the things that my husband and I have talked about is because he's a weather forecaster and we've been to Churchill and things, is that Thompson was in a really good location. And the city of Thompson should be encouraged to put in a sort of aurora tourism place like they do in the Northwest Territories and Yukon. Because it's just far enough up there and it's so dark compared to Winnipeg area.
You are so right.
It would be amazing.
It would be, and Elisa is from Thompson and she thinks the same thing, and we have, she's got some ideas, and she really, one of the things that she would love to see up there is a dark sky preserve, a place for some people to go and set up.
It'd be pretty easy up there.
It should be, but the thing is, there's like all of that place is not accessible. The only place that you might not be able to drive into it during the winter time is Pichu Falls. You can drive into there. There's a little courtyard there, and you could set up there. But I'm not sure if it's plowed all the way in there in the winter time. And all of these beautiful places in Thompson are not accessible in the winter time. And the ones that are, people will abuse it. And so it does need money to maintain that infrastructure, but they are just at the edge of the oval. They are in a beautiful place, and it's accessible by vehicle. Like Churchill, you can't drive up there, right? Thompson, you can.
It's not that far.
No, but Thompson is a great place.
Other questions? Here's one. No.
Okay, your photography is absolutely impressive and tremendous. I'm blown away by every image that you're showing, and I'm just wondering whether you've had an opportunity or have been approached by a gallery or something like that to do an exhibit of your amazing photography.
Well, thank you very much. I love taking photos, and I've got thousands and thousands and thousands of them, and and many favorites. I was approached by a group in Nipawin, Arts Forward, they hosted. What was that art show? Can't remember that art show across Manitoba. And so I was able to show some of my photos with 3 other women who are aurora photographers in the area, and Elisa from Thompson. Yeah, I have had the opportunity. I would love to get into more of that. I'm a little bit shy when it comes to that. I love to talk about the aurora and share the aurora with people and help them see the aurora. But when it comes to showing my work, I'm a little bit shy on that. But it was an incredible opportunity to be able to share it at Arts Forward for the, what's that called? That Flash Photographic Festival. That was what it was called. Whoa, yeah.
Okay, well, if there are no other questions, thank you so much. You're very welcome. And we have a little token of thanks for you. I hope you enjoy it.
Oh, thank you so much.
And Aurora Source seems like a pretty cool thing to get to join up with.
Yes, Aurora Source is amazing, and they have supported me so much. I've learned so much from them, and they were so anxious, and they were so excited that I was coming here to share with you. They said, tell us how many people were here. So that,
Well, I think we know. I think there's 11 and there's about 45 of us here.
that's awesome.
Yeah.
Thank you so much.
Okay,
Yeah, and
thanks, Donna.
there is there are papers here with, if anyone is wanting the QR codes.
Okay.
Or the links there. I do have a digital copy that I can email if anyone's interested in some of those projects and websites, so.
Thank you so much.
Okay, thank you.
And I'm sure that's all for the meeting. We now adjourn to Boston Pizza on Pembina, just south of Chancellor, a couple of blocks. And you're welcome to join us if you like. Very informative. Thanks for coming, and we'll see you next month, March the 13th again,
Yeah.
Friday night.
Yeah.
For all your, what do they call it? Triskaidekaphobia. Fear of Friday the 13th.